welcome back to GalaxyPhi Math. So I just wanted to pop on here and say that I have started my tutoring website. So it's GalaxyPhiMath.com. I will continuously, as always, be putting up math instruction on YouTube for free. But if you need more individualized one-on-one help, and I haven't gotten to that subject yet or posted that video yet for free, I am offering one-on-one tutoring from me. And you can go check it out at GalaxyPhiMath.com. Go check it out. Let me know if you have any questions. There's a questionnaire on there. You can fill that out. Let me know more about you. You can sign up and I'm available. I'm here. I'm here to help. So let me know if there's any videos in particular that you would like me to do for you. Comment below. Thank you so much for watching. I hope you enjoy this video. This particular video is about recognizing different graphs, so your non-linear graphs that the quadratic, cubic, square root, absolute value, and being able to identify them on tests really quickly, and then some kind of ways to figure it out. If you're stuck, you can always pop in some numbers and into the equation and kind of figure it out. Recognizing the graphs is really important, so I definitely recommend doing the little quiz at the end. And as always, I put in the chapters for you so that you can skip ahead, pause, and do whatever. If you need to brush up on anything, it's easy to navigate. So I hope you enjoy this video and I hope it helps you. Thank you for watching GalaxyPhi Math. Please don't forget to like and subscribe. Okay, so now we're going to look at x squared. So f of x equals x squared. F of x is going to be your y. So when you plug a value in for x, such as the values on the left-hand side of the table, you will get y, or f of x, on the right-hand side of the table. And we can do this with x equals 0 for the function x squared, and we end up with 0 squared. 0 times 0, of course, is 0, so y equals 0. And so you have the point 0, 0, which is the origin, and that is where this graph intersects the x-axis. And when you have any of these quadratic equations where the highest exponent is 2, it is going to take the form of a parabola, which is this shape. So it's good to recognize this shape and understand when you're on a test, you can quickly identify it by the highest exponent being 2. And now we're going to talk about some of the variations in the shape of a parabola or x squared. We can talk about a translation. Horizontal translations will be when you have parentheses around either say x plus or x minus 4, x plus 2, and then you square that whole quantity. It's important to understand that the parentheses make a big difference because you're applying that function to the whole expression, not just x, but x minus 4 there. So it's literally x minus 4 times x minus 4. It is not the same thing as x squared minus 4. And so when you do that and you have the parentheses around that expression, you are going to translate to the left or right. If it's a minus sign, you're actually going to end up being positive on the x-coordinate. And if it's a plus sign, you're actually going to be negative on the x-coordinate. But so we can see here, if we plug in x equals 0, we will get actually where this graph intersects the y-axis, and that'll be 16. It's cut off from the view here, but if you just plug it into your graphing calculator, or you can use a free graphing calculator online, you can zoom out and see where that intersects the y-axis. Now, if we look at where x equals 4 there, we can see that that is actually going to end up being where it intersects the x-axis, and that is how we can see that we shifted from the green graph, which was x squared, over to the right at 4. So we're going from 0 to 4. We're just shifting horizontally. And we're shifting horizontally to the right because it's x minus 4 squared. So you can see the difference and pick this out if you're looking at a test and you're not sure whether you go up or down or left or right. You can at least narrow it down and know, okay, well, there's those parentheses there over that whole expression. So it's not just x squared, it's x minus 4 squared. We're going to be going horizontally. And when you're going horizontally, the sign is opposite. So you will be going to the right from x squared. And we'll be at the point 4, 0. So now we are going to look at the graph of x squared minus 4, where the x is the only thing that is squared. And that tells us that we are going to be moving up and down. So we'll be moving vertically. And if it's minus on the graph. So you are actually moving down. And you can see that when x is 0, your y is going to be -4. And those values are on the table on the right, which shows all the values of x and all the values of x squared minus 4, which is our y. So when we plug in 0 for x, we end up with 0 minus 4, which is -4. So we have 0, -4. Okay, another thing we can do is flip the graph over the x-axis, and that is when we just place the negative right in front of the function. So we have negative x squared. So we plug in our x and we square it because exponents comes before multiplication, and you're essentially multiplying by -1 when you put that negative in front of it. So we have exponents first. So we put our x in parentheses, whatever value that might be, whether it's positive or negative, we square it, then we multiply it by that -1. So when x equals -1, in this case, for the function negative x squared, we plug in -1 squared, and we end up with negative times 1. And so we still end up with a -1. So the point is -1, -1. So this is going to be the general graph of x cubed. So anytime you have a graph with the exponent of the highest exponent being 3, this is going to be the general shape of that graph. And just like before, we're going to have some translations to the left or right, up and down, and then we can flip it over the x-axis and, you know, have going in the opposite direction. The biggest thing is to know which way you're going. If you're going side to side, up or down, you know, if you're flipping it, just to know the general shape is a huge deal. So kind of memorize the shapes of these graphs. If you know that the highest exponent in the equation is 3, you know that it's going to have a shape like this x cubed shape. So you see here this translation, just like before with the x squared, it doesn't have parentheses around the whole expression before you cube it, so you're going to be moving it vertically. It's -4, so you're moving it down vertically. You can see on the table on the right the values of x and then the values of y. So this is where we have x cubed, and it looks like this is 2 parabolas, but it's actually 2 cubic functions graph, so pay attention to the colors for sure. But we just flip these over the x-axis again when it's negative, so it will look the opposite direction. Here is the graph of the square root of x. All of these will look like this, with just kind of almost like the top half of a side turn parabola. Here, because we have that, we're taking the square root of that whole expression, so it's in parentheses, x plus 4. Since that whole thing is, you're getting the whole square root of that, it will be horizontally, and because it's plus 4, we're actually moving it to the left this time. For this graph, we are going to move it up because we have the square root of x plus 4. It's not all in parentheses, meaning that it is just the square root of x plus the number 4. So we're moving up vertically to 4. And you can pause these and kind of look at them more closely, graph them yourself for sure, and plug in some values and play with it to really get a good feel. So the red graph is the graph of negative square root of x. Again, it's flipped. So we're just seeing that bottom half with the negative values as opposed to positive values. So the table on the left shows the values for the blue graph, which is the original square root of x. This is the graph of the absolute value of x. Again, we can see the table on the right where we plug in values of x and we get our values of y by plugging it into the function of the absolute value of x. So as you take the absolute value of -3, it's going to be +3. If you take the absolute value of -2, it's going to be +2. So again, we are taking the absolute value of the whole expression x minus 4. So we will be translating that to the right. So we know it's horizontal because we're looking at the whole expression. And we are going to be translating it to the right because it's -4. So we're becoming more positive. And with this one, we are just taking the absolute value of x alone, not the whole expression. So we know it's going to be vertical. It's +4, so we are moving up 4 on the y-axis. So it's the same, these are graphs of functions with the same general appearance as the original, and we're just translating and flipping with some simple additions here. Okay, this is the flip of the absolute value of x. It's negative absolute value of x. So you can see with the table and the values of the table and looking how that relates to the graph of the green graph on the coordinate plane here. So the red is our original absolute value and the green was our negative. Okay, so now we're going to test your knowledge a little bit and just show the general shape of the graphs without giving the guidelines at all, and just see if you can recognize them. So pause it and see if you can get the right answer, and the answer will flash up. As always, you can skip ahead and pause and do whatever you need to do. So that was fun, right? It was a great quiz. I mean, I'm sure you got 100, right? If you didn't, just do it again. But thank you again for watching GalaxyPhi Math. Don't forget to like and subscribe.